Okay, another CIMT question. This one's just mainly question 4 to do with reading distance graphs or distance tables. Distance tables are actually a very special form of a two-way table where you've got each destination across the top. So we've got Cardiff, Bristol, Manchester, Newcastle, Manchester. They're not in alphabetical order. And London. And we've also got where they could depart from, which are the same places. Now, the way the table works is all Cardiff's values go straight down below Cardiff. 45, 181, 119, 135. Oops, sorry, Cardiff doesn't go to itself. 45, 181, 119, 135. And because there's no difference in the two journeys going backwards, we'll assume that there is no significant change in mileage. Yeah, using one-way systems you might do, but for distances across country, generally not. Now, Bristol is the awkward part. So Bristol goes to Cardiff for 45. So the first number for Bristol is going left. Then the next one coming down is Bristol can't go to itself. And then we copy the bottom three columns because this gives me the other three places. This is Bristol to Newcastle, Bristol to Manchester, Bristol to London. So we've got 173, 117 and 93. And the same thing, it goes across as well because there's no significant difference between the two. 173, 117. Lost my pen for the moment. (117) and 93. Keep going on for Newcastle. So Newcastle does 181, 173, already filled in, then 89, 185, coming down. So these dashes are basically the city themselves. You're not going to do any distance going around from a city to itself. And that's basically what this diagram has shown, is this table has 163 in both. And then we're left with London to London. So what they've done to create this table is, we've said that you can't do a Cardiff to itself, so if it labels each of these with the cities, the other parts are duplicates, so they don't need to be pre-printed. Now, some graphs, what they might do is they may do one side is distance in kilometres, one in miles, one in kilometres or miles, one in time, estimated travel times. Plenty of uses for it being two-way, but you need to be able to interpret the single. So, to answer the question Newcastle to London, London to Newcastle, I could go start at London and go to Newcastle, which is 185 kilometres. That's easy off a two-way table. In the simplified form, London is all the distances along here at the bottom. That's London. Newcastle is distances in that column and that row. And we want to see where do the two things overlap. So Newcastle, there's those two and those two. And London is the bottom one. Where the two sections overlap gives me the distance between Newcastle and London, 185. Same as I found when I copied it into a two-way table. Bristol to Manchester, we'll do it on this table first. Bristol across, actually if I do it in a different colour. So Bristol is everything going across from Bristol and down from Bristol. And we want to see where does it link with Manchester, going across, and Manchester reading down. The overlap is there at 117. Bristol to Manchester, 117 in the shaded out. Bristol to Manchester, 117. Which of the cities is closest to Cardiff? Well, there's Cardiff. What's the smallest number in its journey? The 45. What's the alternate to that? Read across to Bristol. So Bristol. I should do that back in my usual purple. So you can read across to Bristol. And Tim drives from Cardiff to Newcastle and then on to London. Well, my graph has got a little bit complicated, so I'm going to erase it so I can see all my numbers. And now I can do Tim drives from Cardiff to Newcastle, which is 181. And then from Newcastle to London, so he's in Newcastle, comes down to London. So where can I do the turn to go between the two cities? Newcastle to Cardiff, Cardiff to Newcastle, turn at the 181. Newcastle to London, if I go along here, no, I've got to go all over the place. Newcastle down and then turn to get to London, 185. Add the two together and it's 6, 6, carry 1 is 366. And that's how you can use these distance graphs, which are a special form of two-way table.